Hello everyone, it's lecture 7 by iTuner's Academy Nature of Polynomial Roots, and let's start with the fundamental theorem of algebra, which states that every polynomial equation f of x equal to 0 has at least one real or complex root. Okay, and here is the statement of the fundamental theorem of algebra. Here are some substatements of a theorem of algebra. Okay, the first is for any polynomial f of x equal to 0, the number h is a root only if f of h equal to 0. Okay, the second is the equation f of negative x equal to 0 has roots which negative 2 roots of f of x. Okay, if we have f of x equal to cubic x negative 13x plus 12. Okay, this equation has roots of negative 4, 1, and 3. Okay, then from this statement we can obtain the roots of f of negative x, which equal to negative cubic x plus 13x plus 12. The roots of this equation will be 4, negative 1, negative 3. Okay, and the last one from this substituent is the number of negative roots of f of x equal to number of positive roots of f of negative x. Okay, nature of polynomial roots. The roots of polynomial equation can be rational roots, irrational roots, and imaginary roots. Okay, so what's meant by rational? So rational number, I can say this number is rational only if can be written in this form: P by Q. Okay, and if this number can't be written in this form, I say this number is irrational number. Okay, so the first is rational roots of polynomial equation. If I have f of x equal to 0 with integer coefficient of x bars and the coefficient of the leading term is q and b is the free term of the polynomial equation, then all possible rational roots can be plus or minus the divisor of b by divisor of q. Okay, and for rational roots, if I have polynomial equation f of x equal to 0 has a rational coefficient of x bars and the irrational number a plus square root of b, which can't be written in b by q, is a root of the polynomial equation, then the conjugate irrational number a minus square root of b must be a root. Okay, so if I have here 3 plus square root of 5, this is an irrational number, and if this number is a root of any polynomial equation, the 3 minus square root of 5 must be a root of this equation. Okay, and for imaginary roots, if I have polynomial equation f of x equal to 0 a real coefficient, and imaginary number a plus aib is a root of the polynomial equation, then the conjugate number a minus ib must be a root. Okay, so if I have 3 plus 2i is a root of f of x, then 3 minus 2i must be a root of this equation. Okay, let's verify all of this by an example. Just here. So the first example on rational roots is find all possible rational roots of x power 5 minus 2 x power 4 minus 9 cubic x plus 22x plus x 4x minus 24 equal to 0. Okay, so we have here q equal to 1 and b equal to 24. Okay, okay, so here if we have b, the divisor of b are here, b can, the divisor can be 1, 24, here 2, 12, here 3, 8, here 4, 6. Okay, so we have here 1, 2, 3, 4, 6, 8, 12, 24 divisor. Okay, but we must put here plus or minus for all. Okay, as we can obtain 24 by two ways. Okay, always by two ways. Okay, and we have here q, so the divisor of q is plus or minus 1. Okay, so let's start here. All possible rational roots can be here. Here, if we divide b by q for each divisor, so we obtain here plus or minus 1, here plus or minus 2, plus or minus 3, plus or minus 4, here plus or minus 6, plus or minus 8, plus or minus 12, here plus or minus 24. Okay, so here to obtain the rational roots, we just try every number of these possible roots. Okay, so let's start with 1. Here we have 1, and the coefficient of this equation is 1, negative 2, negative 9, here 22, here 4, and negative 24. Okay, by sensitive division we can proceed this division, and if 1 is a root of f of x, this polynomial equation, the remainder of this division will be equal to 0. Okay, here from this. Okay, so let's just start here in third line. 1 1 by 1 here, 1 -1, -1 by 1 here, -1 here, -10, -10 into 1 equal to -10. So we have here 12, 12 into 1 equal to 12. Here we have 16, 16 into 1 equal to here 16. So we have here -8. So 1 is not a root of f of x. Okay, just continue to -1. So let's start here. We have 1, -2, -9 here, 22 here, 4 here, -24. So let's start again. 1 and 2, -1 equal to -1. Here we have -3, -3 and 2, -1 equal to 3. Here we have -6 and 2, -1 equal to 6. So we have here 28, 28 and 2, -1 equals to -28. Here we have -24, 24 and 2, -1 equal to 24. So we have here, we obtain here remainder equal to 0. So -1 here is a root of f of x. Okay, we obtain here the first root is -1 here. Okay, and obtain this quotient into the factor of x plus 1. So just write this equation here. Here we have x power 4 minus 3 cubic x minus 6 x squared plus 28x minus 24 this into x plus 1 equal to f of x. Okay, so just clear this and continue to the next number of possible roots here. Here we have plus or minus 2. So let's start with 2. So we have here 2. And here we want start again with the polynomial equation f of x. Okay, just start with this quotient as if this quotient is divisible by 2, then f of x also divisible by 2. Okay, so let's start with the quotient. Okay, here we have 1, -3, -6, 28. Here we have -24. So let's start here our synthetic division. 1 into 2 equal to 2. So we have here -1, -1 into 2 equal to -2. That's equal to -8. -8 into 2 equal to -16. So we have here 12. 12 into 2 equal to 24. So we have here 0, the remainder. So 2 is a root of f of x. Okay, so here we have 2, also a root. Okay, let's continue with this, sorry, with this question. Here we have cubic x minus x squared minus 8x plus 12 is the quotient of this division, and the remainder is 0. Okay, so we have here negative 2, here we have 1, 1 into negative 2 equal to negative 2, here we have negative 3, negative 3 into negative 2 equal to 6, so we have here negative 2 into negative 2 equal to 4, we have here remainder is 16. So negative 2 isn't a root of f of x. Okay, let's move to the next number here, plus or minus 3. Okay, okay, we have here 3. So here 1 into 3 equal to 3. Here we have 2. 2 into 3 equal to 6. We have here negative 2. Negative 2 equal into 3 equal to negative 6. So we have here 6. We don't obtain the remainder equal to 0. Then 3 is not a root of f of x. So just clear that and move to next number. Next number is negative 3. We have here 1. 1 into negative 3 equal to negative 3. Here we have negative 4. Negative 4 into negative 3 equal to 12. Here we have 4. 4 into negative 3 equal to negative 12. Here we obtain remainder is 0. Then negative 3 also a root of f of x. Okay, so we have here 3. Okay, so just clear that and write this question. Okay, so from this roots and this question, f of x will be equal to x squared minus 4x plus 4 into x plus 1 into x minus 2 into x. Here we have negative 3, so we have here x plus 3. Okay, just we can factorize this bracket by here. We can obtain x minus 2 into x minus 2 into x plus 1, x minus 2, x plus 3. Then all roots of this equation are roots of f of x. Here are x equal to 2, x equal to, x equal to, x equal to negative 1, x equal to negative 3. Okay, so let's proceed another example on rational roots. Just clear this. Find all possible rational roots of x power 5 here plus 2x power 4 minus 18 cubic x minus 8x squared plus 41x plus 30 equal to 0. Okay, so we have here b equal to 30, q equal to 1. We have here the divisor of br 130. Here we have 2, 15. Here 3, 10. Here 5, 6. Okay, and this is plus or minus. Don't forget this. As always, we can obtain 30 by two ways. Okay, here q, the divisor, is plus or minus 1. Okay, so all possible rational roots can be here plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, plus or minus 30. Okay, so again, let's start with synthetic division on the first number, positive 1. So we have here 1, and the coefficient of this equation are in descending order 1, 2, negative 18, negative 8, here 41, and third here, and third line. Here we have 1, and third line 1 into 1 equal to 1, 3 plus 1 equal to, sorry, 2 plus 1 equal to 3, 3 into 1 equal to 3. So we have here negative 15, negative 15 into 1, negative 15. This equal to negative 23. Negative 23 into 1 equal to negative 23. We have here 18. 18 into 1 equal to 18. So we have here 48. So the remainder here isn't 0. Then 1 is not a root of f of x. Move to the next number here. So we have here again with the base equation of x here, again with negative 1 here, 1, 2, negative 18, negative 8, 41, 30. So here we have 1, 1 into negative 1 equal to negative 1. Here we have 1, 1 into negative 1 equal to negative 1. Negative 1, here we have negative 19. Negative 19 into negative 1 equal to 19. So we have here 11. 11 into negative 1 equal to negative 11. So we have here 30. 30 into negative 1 equal to negative 30. So we have here remainder is 0. Then negative 1 here is a root of f of x, and we have here the first root is negative 1. Okay, So just clear that and start from this quotient. As we have here, the remainder equal to 0. Okay, so just write this here. So we have here x power 4 plus cubic x 19x squared here plus 11x plus 30. Okay, u of x. Okay, so just clear this, all of this. Okay, and again start with the number 2. Okay, plus or minus 2, let's start with 2, and we have here start with the quotient. As we had the remainder as 0, so here we have 1, 1, negative 19, here we have 11, 30. Okay, again 1, 1 into 2 equal to 2, 1 plus 2 equal to 3, 3 into 2 equal to 6, we have here negative 13, negative 13 into 2 equal to negative 26. We have here negative 15, negative 15 into 2 equal to negative 30. So we have here 0, the remainder, then 2 as a root of f of x. Okay, again, so we have here 2 new root. Okay, here just continue with this quotient. As we have here, the remainder is 0, so just here to the next number, negative 2. Here we have 1, 1 2 into negative 2 equal to negative 2. Here we have 1, 1 into negative 2 equal to negative 2. This is equal to negative 15. Negative 15 equal into negative 2 equal to 30. So we have here 15. Then negative 2 is not a root of f of x. Okay, so just clear and move to another root. Here we have 3. So 1, 1, 2, and 2, 3 equal to 3. So we have here 6. 6 into 3 equal to 18. 18 negative 13 equal to 5. 5 into 3 equal to 15. So we have here remainder is 0. Then 3 is a root of f of x. Then 3 is the new root here. Okay, so we have here this remainder 1. So just clear this and rewrite f of x as we reach the power of square. So here we have f of x equal to this quotient x squared plus 6x plus 5, this into x plus 1 from this root, x minus 2 from this root, and x minus 3 from this root. Okay, so we can just easily factorize this bracket into x plus 1 into x plus 5 and continue x plus 1, x minus 2. Here we have x minus 3. Okay, so the roots are negative 1, here negative 1 again, here negative 5. Here we have 2 and 3. Okay, there are the roots of this equation. Okay, so just clear this and move to another example on rational roots of polynomial equation. Another example on rational roots here 12x power 4 here minus 4 cubic x minus 5x squared plus 45x here plus 18 equal to 0, and want to find all possible rational roots of this function. Okay, so here b equal to 18, q equal to 12. Here the divisor of b will be 1, 18, 2, 9, here 3, 6, here, and the divisor of q is 1, 2, the first divisor is 1, and the divisors are 1, 12, here 2, 6, 3, 4. Okay, and here we can obtain all possible roots, or here plus or minus 1, plus or minus 2, plus or minus 3, here plus or minus 6, plus or minus 9, plus or minus 18, here plus or minus 1/2, plus or minus 3 by 2, here plus or minus 9 by 2, plus or minus 1/3, plus or minus quarter, plus or minus 3 by 4, here plus or minus 6, plus or minus 1 by 12. There are all possible rational roots of this equation, and again start with 1, okay, and proceed your synthetic division to obtain all roots of this equation, all rational roots of this equation, okay, by synthetic division. The remainder will be equal to 0. Then this number is a root of this equation. Okay, let's remove. I hope rational roots of polynomial equation is clear. Now let's find all roots of 4x 4 here, 3x or 3, 4x here plus 3 equal to 0. Here we have p equal to 3, q equal to 4, then p all divisor of b are 1, 3, plus or minus here, plus or minus, and q here, sorry, this B, and this is Q. Okay, okay. Q 1, 4, and here 2. Okay, plus or minus, plus or minus, plus or minus. Here we have minus, plus or minus. Okay, then all possible roots are plus or minus 1 here, plus or minus 3, plus or minus 1 half, plus or minus 1 quarter here, plus or minus 3 by 4, plus or minus 3 by 2. Okay, so let's start. And here, if we notice here, we have an odd power of x. Here we have negative sign. Then all negative roots can be eliminated. Then if we substitute with any negative number here, the result will be positive number. Then it won't be ever 0. Okay, then we will start with 1. Okay, we have here 1, 4. Okay, 0, as the coefficient of x squared is negative 4, 3. Okay, here we have 4. 4 into 1 equal to 4. Then we have here 1. 1 into 1 equal to 1. 1 plus 0 equal to 1. 1 into 1 equal to 1. Here we have negative 3. Negative 3 into 1 equal to negative 3. So we have here 0. Then 1 here is a root of f of x. Okay, let's continue with this. 2, 3. Okay, so let's start. Here we have 4. 4 into 3 equal to 12. This 13. 13 into 3 equal to 39. Here we have 40. 40 into 3 equal to 120. Here we have 117. Then 3 is not a root of this function. Okay, let's try another one. Here we have 1 half. Here 4. 4 into half equal to 2. We have here 3. 3 into 1 half equal to 3 by 2. This equal to 5 by 2. 5 by 2 into 1 half equal to 5 by 4. Then we have here negative 7 by 4. Then we don't obtain a remainder is 0. Then we can try another number. Let's try 1 quarter. Here we have 4. Okay, 4 into 1 quarter equal to 1. 1 plus 1 equal to 2. 2 and 1 quarter equal to half. So this equal to 3 by 2. This equal to 3 by 8. And this equal to negative 21 by 8. Then isn't equal to 0. Then try another one, another positive one. 3 by 4. Here we have 4. 4 into 3 by 4 equal to 3. This equal to 4. 4 into 3 by 4 equal to 3. This equal to 4. 4 into 3 by 4 equal to 3. Then we have here 0. Okay. Then here 3 by 4 is a root of f of x. Okay. We have here 1. We have here 3 by 4. Okay. So, and we obtain a quadratic function. We have here f of x. Okay. We have here f of x equal to 4x squared plus 4x plus 4 into x minus 1 x minus 3 by 4. This will be factorized to just we can divide by 4, so we have here x squared plus x plus 1 equal to 0. Then x here equal to negative 1 plus or minus square root of 1 minus 4, okay, by 2. Okay, this equal to negative 1 plus or minus I square root of 3 by 2. Okay, then our roots are here, roots of f of x are here we have 1 3 by 4, and the other two roots are negative 1 plus or minus I square root of 3 by 2. Okay, I hope this clear. Form the lowest degree polynomial equation with integer coefficient f square root 5 and 2 minus 3i are roots of equation. Okay, from the irrational roots and the imaginary roots, we have to say f square root of 5 is a root, then negative square root of 5 must be a root. Okay, again with imaginary number f, 2 minus 3i is a root, then 2 plus 3i must be a root. Okay, Okay, then we have here the all factor of this equation. Here we have four roots, so we have a 4-degree polynomial equation. Here we have x plus square root of 5 into x minus square root of 5 into x minus 2 minus 3i into x minus 2 plus 3i equal to 0. Okay, so we have here from this two brackets we can obtain that x square minus square root of 5 is 5. Then we have this two brackets. Here we have x square minus, here we have x square minus, here we have negative 4x plus 2 minus 3i into 2 plus 3i. Okay, then we have here x square minus 5 into x square minus 4x plus, here we have 4 plus 9 equal to 30. Okay, so we have here x power 4 here minus 4 x square, here x power 3, sorry, here plus 13x square minus 4x 5x square plus 20x here plus 65. Okay, so we obtain here x power 4 here minus 4x 4 cubic x here plus 8x square plus 20x plus here, or minus, sorry, here we have minus, as we have 13 into negative 5, so we have here minus 65. Okay, this is the final equation of this roots, this given roots. Okay, we have here minus. Okay, okay, as we know earlier in this lecture that f a plus ip is a root of f of x, then a minus ib is a root of f of x. Okay, then we have to say the number of imaginary roots of any polynomial equation must be an even number. Okay, and if we have here x power 3 minus 2x squared plus x minus 1 equal to 0. This polynomial f of x we can say f of x has three variation of we can say that f of x has three variation of signs, okay, between cubic x and negative x squared, okay, between negative x squared and x, and then between x and negative 1, okay. Okay, now we have to talk about Descartes' rule of signs, okay. With this rule we can obtain the number of Descartes' rule of signs said that the number of positive real roots of f of x equal to the number of sign variation, or the number of sign variation dimensioned by an even number, okay, and we are sure that this even number is the number of imaginary roots, okay. Okay, and here the number of negative real roots of f of x equal to 0 equal to the number of sign variation of f of negative x equal to 0, or that number dimensioned by an even number, okay, and this even number is also a number of imaginary roots, okay. If we write x power 5 plus x power 5, sorry, x power 5 plus 4x power 4 plus 2 cubic x minus 5x squared plus x minus 3 equal to 0, okay. This equation has 5 roots, okay. Then just we will divide this by real roots and imaginary roots. So number of real roots can be 5, can be 3, can be 1, okay, and the number of imaginary roots can be 0, 2, and 4, okay. I hope you use Descartes' rule to obtain the number of real roots, and here we have x 2x power 5 minus 4x power 4. Here we have 9x minus 2 equal to 0, okay. So the first step is to obtain f of x equal to 2x power 5 minus 4x power 4 minus 9x minus 2, okay. Then here we have only one variation of sign. Okay, so here f of x has only one positive rule. Here positive has one positive root. So f of x has only one positive root or none. Okay, can be 0. Okay, again, the second is to obtain f of negative x. So we have here negative 2x power 5. Here we have minus 4x power 4. Here plus 9x minus 2. Okay, so we have here 1, 2, two variation of signs n f of negative x, then f of x has only two negative roots or has no negative roots. Okay, so here f from f of negative x, f of x has 2 or 0, and from this the imaginary roots can be 2 or 4. Okay, here if f of x has one positive and has none of f of negative x, then the imaginary roots is 4, and f have 1 and 2 negative roots, then the imaginary roots is equal to 2. Okay, let's move to another one. Here we have if we here if we have x or 3 minus 3x squared minus 4x plus 12 equal to 0, then f of x equal to cubic x 3x squared 4x equal to 0. So we have here from f of x from f of negative x. Here we have 1 f of x has two variation of signs. So here we have two variation of signs. Then f of x has two or 0 of positive roots. Okay, again with f of negative x equal to negative cubic x, here minus 3x squared plus here 4x plus 12 equal to 0. So we have here only one variation sines, then here f of x has one negative root. Okay, so f of x here has 2 or 0. Okay, and here f of negative x has 1. Okay, so here the imaginary roots can be 2 if the positive roots equal to 0 and negative roots equal to 1, then the imaginary roots will be 2 or 0 if the positive roots equal to 2 and the negative roots equal to 1. Okay, another one. Okay, if we have x power 5, x power 5 here plus x power 4 plus 4 cubic x plus 3x squared plus x plus 1. Okay, first f of x equal to x power 5 plus x power 4 plus 4 cubic x plus 3x squared plus x plus 1. F of x has no variation of signs, then has no positive roots. Okay, here real, imaginary. Here we have 0. F of negative x equal to negative x power 5 plus x power 4 plus minus 4x 3 plus 3x squared minus x here plus 1. So we have here 1, 2, here 3, 4, 5. So we have here 5 variation of signs, then f of x has 5 or 3 or 1 root negative. Okay, so we have here 5 or 3 or 1. We have here no choice as the positive real roots is 0. Okay, so we can obtain here imaginary roots 4 or 2. Okay, or 0. 0 if the negative is 5, 2 if the negative roots is 3, and 4 if the negative root is 1. Okay, I hope all of that clear. The Descartes rule of science and the nature of polynomial roots. and thank you.